Want we hebben hier een hele interessante tafel. We hebben ook nog iemand op afstand. En die is de Nederlandse taal onvoldoende machtig. So I will be continuing in English. The Netherlands has a strong position in the chemical industry, in energy production, in manufacturing. I think most of you know this. And if we can make a connection between these sectors, between these industries, in the process of sustainability, we can take steps further, more steps to use CO2 as a raw material. But what are the challenges? What is technology advancing fast enough? Are industries actually really working together? And of course, bottom line, is there a profitable business case yet? Or will there ever be? To discuss this and other topics, I would like to welcome 4 distinguished guests. The CEO of Avantium, Tom van Aken. Welcome.
Thank you.
CEO of Vattenfall, the Netherlands, Martijn Hagens. Welcome, sir. The Chief Technology Officer of DSM, Mr. Marcus Remmers. He's online. Mr. Remmers, a very warm welcome.
Thank you. Pleasure to be here.
Thank you, and you're coming in loud and clear, so that's perfect. That's also a relief for a presenter that he can see someone and hear him, so that's fine. And last but certainly not least, the Program Director Energy Innovation at the University of Twente, Jos Keurentjes. Welcome to you as well. Maybe a quick introduction of your companies, perhaps, or your activities. I'll start with you, Mr. Hagens.
Thank you very much. Well, Vattenfall is a large energy company in Northwest Europe, mainly active in the Nordics, Sweden, and in Germany and the Netherlands. Most people in the Netherlands know us still by the brand Nuon, but that has changed to Vattenfall already for quite a while. And we're in the Netherlands one of the largest producers of renewable energy.
So now you call the name Nuon, now everybody's going to think Nuon again.
Yeah, I know.
Sort of the elephant in the room.
The elephant in the room, but it's Vattenfall.
You started there at the beginning of this century, 2002?
2003, yes.
2003, okay. And now the CEO. And a member of the board of Vattenfall Group.
Yes.
Okay, so commuting quite a lot. Well, not at the moment.
Well, not at the moment, but normally, yes.
Okay. Tom van Aken, Avantium. I think most people know the name Avantium, but I'm not really sure if everybody knows what exactly it is that you do at the company.
Well, that's a pleasure to tell. We are a company in renewable chemistry. So we start from renewable sources of carbon, meaning plant-based sugars or CO2 as a feedstock. And we convert that into chemicals and plastics. And we are, I think, most famous for a new bioplastic, PEF, that we are developing, which is seen as the next generation packaging material. So this topic of CO2 is very close to our business.
Yeah, you are developing. It's not finished yet.
No, we are in the final stages of engineering our first commercial scale plant in Delfzijl. Mm-hmm. But we have a pipeline of new technologies that we are developing and scaling.
Okay.
That is a time-consuming and capital-intensive activity. So, of course, we look for partners and investors to help us to bring these new products to the market.
Already working at it for 20 years. You're a CEO for 15 years already.
Correct.
One of the longest.
Yes. Longest when I became CEO in 2005, everyone was just complaining and wondering why someone at 35 was CEO. 15 years later, no one is talking about it anymore. So that is one of the only changes.
Yeah, and finally, Avantium is a spin-off of Shell.
Yes, we started in 2000 as a spin-off from Shell, but Shell has sold its shares already long ago. We're now a stock-listed company on the Euronext stock exchange.
Nothing to do with Shell.
Correct.
Okay. Mr. Keurentjes, what does an Energy Innovation Program Director at the University of Twente do?
I was hired about a year ago by the University of Twente based on the fact that there is a significant number of researchers active in the energy domain, and not just a few. It's approximately 1,000, so that's really a significant number, but it was relatively incoherent and with that not very visible. So what we are doing now is creating coherence in specific programs, and also making it visible what the extremely large knowledge base is that can be used for all kind of relevant activities. I should say a focus of what we do is very much in creating a handful of mission-driven programs, and with that finding application. Well, not just doing academic research, but very much focusing on the application in the real world. With that, I would say we fit pretty much in the setting here today.
Yeah, and before you worked, amongst other companies, at AkzoNobel as corporate director of technology, correct?
Correct.
And you were a member of the board of TNO.
Yes, those were my previous roles.
Of course, not at the same time.
And with that, I bring quite a bit of a network that helps to develop the programs in Twente now.
You're a networker,
That's
so to speak.
part of my job, so to say.
Okay, thank you very much. Mr. Remmers, DSM, never heard of the company. What do you do?
Yeah, never heard of this. I'm sure you may not be aware that we were founded in 1902. And do you know what DSM actually stands for? The Dutch state mines at the time, but you know, we've reinvented ourselves a couple of times since then. Today we're still a Dutch company, but the majority of our 20,000 people also work outside the Netherlands. We're not state-owned anymore. We're, of course, publicly traded at the stock exchange in Amsterdam. And we're certainly not a mining company. Today, we are a leader of nutrition, health, and solutions in sustainable living. And as such, we'd like to think today DSM really stands for doing something meaningful. We see ourselves as a company that's purpose-led, performance-driven. So the doing well and doing good is part of our genes, equally important. And as such, as Chief Technology Officer overlooking our 2,000 scientists, working towards solutions in the space of sustainability is an excitement and humbling, and I love it every day more.
Yes, and you recently had a leadership change, I believe.
Yeah, after 13 years, Feike Siebesma went into his well-deserved retirement, and we now have a set of co-CEOs, Geraldine Metschit and Dimitri de Freze, that took over last spring and continue in the tradition of DSM sustainability journey.
Yeah, and how is a dual CEO position working out so far?
I think you read it in the Dagblatt a couple of days ago, where they really talked in detail about the importance of being aligned and also the power of having a duo that allows you to do things in different ways. I'm curious, Martijn, how you see on it, and if that would work for you, but certainly for DSM it works really well.
Okay, thank you very much. We're going to talk about technology, collaboration, of course, the business case. I said it before. But before we do, I would like to ask the four gentlemen one specific example they're working on right now with CO2 as a what?
Well, we're trying to reduce it, actually.
Yes. Well, as a feedstock, as a building block, of course. Mr. Hagens, Vattenfall, what are you working on?
Well, Vattenfall has the mission to be fossil-free within one generation, so let's say around 2040 to 2045.
I've heard this before, this slogan, I think.
Yes,
maybe once,
maybe
twice.
once or twice, and that is important. I mean, the term was already mentioned, being purpose-driven, and this is our purpose. And one of the projects that we're working on very specifically now is in Sweden. It's called Hybrid, and that's an initiative together with a steel and a mining company where we have built a pilot plant, and that seems to work well. So we're now going to build a scale-up plant for creating fossil-free iron.
Yes.
So replacing the coal in the manufacturing process of steel with hydrogen, basically. And we are, of course, the party that then delivers the renewable energy and creates the hydrogen and works on storage solutions as well.
Yeah, and that's with the company who's planning or aiming or wants to buy Tata Steel in the Netherlands.
Yes.
Are they going to? Maybe you have some inside information.
I wouldn't know that, but if they would do, I mean, I'm knowledgeable of having a Swedish mother company, and for me it works well. So.
Okay. Mr. Van Aken, you already mentioned in Delfzijl. Is that the project you're working on at the moment, and what is it exactly?
Well, I think most people know us from plant-based sugars, but I think the project I would like to highlight today is we also developing a new technology that uses CO2 as a feedstock. So we use CO2 that comes as a waste product from making energy or making fertilizer or making bioethanol. And using electrochemistry, so using an electrical cell, we convert that into chemicals. And by doing that, we basically use the waste as a feedstock. And of course, we basically use that feedstock then to make something really valuable. So we believe that that is one of the real meaningful ways to help to solve this problem, as it turns really, the product that I think is causing all of these issues, and turn it into something that's valuable, where we're now using alternative feedstock to make that. So it's a new technology, and I think something where there's a lot of excitement about this, about the promise it holds for the future.
Yeah. Mr. Keurentjes, is there a project that's close to your heart, which is a great example of what we're talking about here today?
Yes, very much. And I would like to say, going one step further than Tom is going, taking as a starting point that if we want to achieve the Paris climate goals, we won't get there just by reducing our emissions. We really need to reduce atmospheric CO2. And that's a huge challenge. And there is a whole set of technologies that is currently coming into place. They're called negative emission technologies, basically focusing on grasping the CO2 from the atmosphere. Mm-hmm. Of course, nature does that for a part. But there is also, from a technological perspective, quite some basis to do so. Of course, 400 ppm as a starting point is not really helpful. But
do you have a specific project which is tackling these issues?
This is a program, and one of the things that we are looking at is, can you use technologies to reduce CO2 in such a way that you create carbon, which you can use as a raw material in the chemical industry. There's quite a market for carbon as such, but also you can store it if you want to. And doing that in an energy effective way, that is quite a challenge. And we do have some ideas how to solve that issue. But once again, that is just one project in a whole program where we aim at setting up those technologies.
Okay. Mr. Remmers, DSM, big company, lots of projects, obviously, but which is something, what's a project, again, close to your heart, if we talk about CO2 as a building block?
Yes, DSM, we've signed up to the science-based targets with a commitment to reduce our emissions by 30% 2030 and then towards carbon neutrality in 2050. And I agree with yours, the relatively easy part is the 30%. You know, there's projects and awareness. The tricky part is really you have to reinvent the way you work and what you do towards carbon neutrality. And one of the projects that we're evaluating there is how to make our Delft ecosphere carbon neutral by making a combination of capturing the carbon dioxide that comes out of our fermentation there and marrying it with renewable energy as a feedstock that we can on the spot feed back into the fermentation vessels. A lot of pieces of technologies are already known in that context, but we also have to create ecosphere where we invent others that don't yet exist to make this feasible.
So, Mr. Hagens, talking about technology, DSM still needs to develop, to invent technologies. In the project you were talking about, a coal-free steel production, CO2-free. Are all the technologies there, or do you also still, or do they still have to invent technology?
Well, we have produced steel in this way, so the technologies are there, and the real challenge is how to make it scalable. So how to scale it up in such a way that it's still cost efficient. And that is what we're working on now, and the promise that this holds, so that's what we're aiming for, is by 2030 to be able to produce this on industrial scale. And the price tag will be, as we see it now, about 20-30% more expensive. But for example, in a car, that would mean that your car would go up in price by 1 or 2%. I would happily pay 1 or 2% additional for a car if I know that it's produced in such a way. So this is the way we look at it. And of course, this additional price tag that we see currently could change dramatically because that's based on current pricing. So if, for example, CO2 tax goes up or ETS comes into play into these kinds of production processes, then that business case will become more positive. But the current challenge is that we believe that we still need about 7 to 10 years to really develop the scalability of it.
Yes, scalability, but the technologies are there.
The technologies are there.
Okay, Mr. van Aken, how are you on the technology front? Are they there? Do you have to invent stuff, or?
No, I think if you look on electrochemistry, this is technology that people have been working on for years, and in certain things it's being applied on a large scale. But really, if you want to use carbon, so CO2 as a feedstock, that is hardly actually being used on some scales, and that is really where new technology has to be developed. So I do not believe in people that say the technology is all there, it's just a matter of implementation. I think the world needs huge new sorts of generations that need to be scaled, that need to be developed, that need to be enhanced. And what we're seeing right now is, I think, just the top of the iceberg. I think we have to go a lot further to make this a successful change. And therefore, it's also really something that's attractive for new people that are looking into this. So if you're a student and you study chemistry or physics, I think this is a great time to start working in this industry, because there is a phenomenal amount of new discoveries and inventions that are needed to become successful. So we're not there yet, but I think we're slowly moving towards that situation. I think Martijn is rightfully pointing out there are different things that can accelerate this in making it successful. If you apply carbon tax, or if you reduce the energy cost, that of course will help these business cases. But new technology is something that we will see being developed over the coming decades, I'm sure.
Yeah, Mr. Keurentjes, you're now working at a technical university. Is technology a showstopper, or is it just a matter of scaling up, inventing, we can do it, or is it a showstopper?
Technology as such is maybe not, but what I've seen in the past 20, 30 years is that for the large companies involved traditionally in chemistry and petrochemicals, they have an enormous invested capital in the form of steel and equipment. It is not so easy to make investment decisions that involve billions, and that's what we are talking about here. So my expectation would be that if that can develop, we need companies like Avantium that pick this kind of technologies up and bring it to a next level. This is not, well, probably it is the large companies are capable of doing so, but it is not so much in their nature. So I guess this is really going to change the total playing field of companies involved.
Mr. Remmers, is that true? Is it not in your nature?
Yeah, I beg to differ.
I thought so.
With size certainly comes a degree of administration, but we'd certainly like to think in the innovation space that we work a lot with external partners because we know we can't do it alone, but we certainly also invest a lot in processes that are fast and agile, because in this game nobody's waiting for anybody. We need to be out there and the first, and we don't have all the answers, so the best way is to experiment and learn a lot and adjust your course as you go. And you can't do this with a 5-year plan thinking that you are one big organization. It has to be in small agile groups that follow the different technologies. And we don't know today which technology is going to win, frankly, because there's a lot of uncertainties. So the best way is to get engaged in the different ecospheres and bring our technology where we feel we can make the biggest difference, but also interact with others that can complement this in the best way.
Yeah, Mr. Keurentjes, can you help Mr. Remmers in some way? What can you offer him?
What we can offer is at least a perspective that goes beyond the, let's say, the 5 or 10 years horizon. If we take as a starting point that 2050 is going to be the year in which we have no longer fossil sources coming into the system, then we need to be ready. And knowing, well, if you see the scale at which this needs to happen, 10 years in big industry is just one stop further. So what we can do is proposing all kind of schemes and the basic technology to be further developed in, let's say, the 10-15 years to come. Because if you do it that way, then you would be able to have something really new in place when it is 2040, 2050. And that sounds far away, but in this type of activities, that's really tomorrow. And I would say creating this sense of urgency is really something that all of us need to do, because I quite often see companies and people being a bit reluctant in making the big steps that are needed here.
Mr. Remmers, are you going to give Jos a call?
Sorry, can you say it again?
Are you going to give Jos a call?
Absolutely. I'm thinking we would probably have a couple of things that we should discuss together. Let's do that.
Okay, I have a question here from one of the viewers to the industrial partners. It's the three of you. How can the industrial partners at the table help to increase the speed of development at universities, especially in the field of CO2 harvesting? Mr. Hagens.
Well, we're maybe not so active in the CO2 harvesting, although it would be part of the solution because we know how to reduce, let's say, 70 to 80% of our carbon emissions by 2040. And the rest, we still need new answers. So I also agree, we still need a lot of innovation to get where we need to be.
You have one generation time, so you have to
one
hurry up.
generation at a time. So
you will have to harvest.
Yeah, but we also know, and there I really agree with what Jos said, you have to backtrack. So if you start doing that as a company, and we've done so, then you find out, okay, we don't have the answer to 20 or 30% of this issue yet. So we need to find those answers. And harvesting could be part of that, especially if you harvest it for good use. And that's where we could connect again with industry that uses a feedstock. Because I think one of the big problems with harvesting CO2 has been that we then put it underground and then everybody goes berserk because they don't believe that that is a good idea. And we have seen that in the past. That technology is also there. CCS is there, especially on power plants. So, but if you could use it in a different way, of course, this would definitely help.
Yeah. Mr. Van Aken, do you work with universities yourself to increase the speed of development? Technology?
Yes, we do. We actually, our CO2 conversion lab is located at the Amsterdam University, the Science Park here in Amsterdam, or in Amsterdam. And we have many collaborations with other companies and academic institutions. Also on the area of how to actually source the CO2, if that's through direct air capture or taking it out of industrial streams. So we believe that we can only do this together with other companies. And there are many, I think, collaborations like this already ongoing. And Avantium is, I think, a very good example of how companies in let's say, the very exciting phase of development collaborate with other companies to see how they can cross-fertilize and go faster. So I think this is what we are doing, and I'm actually see the question more as a recognition of this type of collaboration, because it would be good if other companies would have the same mentality.
Yeah. Mr. Remmers, you're located in Delft, the factory you were talking about. How's your relationship with the technical university over there?
We're working very closely together. In fact, we've got a couple of partnerships where we're exploring, to Ron's point, electrochemical ways to transfer the energy, electrical energy, directly into microorganisms and not through sugar or chemical waste. Now that's maybe 3 generations ahead, but exactly as you say, it feels we have plenty of time, but we have no time to lose, and we have to invent these really bold and new steps today so that we're ready by the time we need them. Can I just add perhaps one other element to put it a little in perspective? I think the use of carbon dioxide still for me is always the second best option. The best option at this stage is to avoid generating it in the first place, because by the time it's already there, you have 2 problems. One is the first law of thermodynamics, and the second is the second law of thermodynamics, because you got a lot of energy out when you generated it, but you of course has to put a lot of energy back in to do something useful with it, and you have to concentrate it, which is another very energy intense process. So as long as we generate most of our energy from fossil fuels, our limited renewable energy, I think, should go primarily in replacing fossil fuels power plants. But still, we need to start today to invent these new technologies down the road to get the carbon dioxide back out of the atmosphere.
Yeah. Mr. Keurentjes, when I talk to companies, they always say, no, we work close with technical universities. And is this in fact true? Just tell me, is this true? Or do you have some a wish list regarding companies?
Yes, I definitely do. But what we see is that there is a change in the way of working together, where it used to be a connection on the level of individual smaller projects. What I now see is that companies, to a large extent, prefer to be in a larger ecosystem, where not is just a bilateral collaboration, but where all parties from the total value chain are present, and you develop together. You have the fundamentals that typically comes from the university. You have the translation into pilots, into larger things, and in the end, the company needs to pick it up and really make it a production facility. And the thing that you do it, the fact that you do it together, really helps you to ask the right question for the fundamental developments, and it also ensures that the things that are being developed really find a landing place in real life, which traditionally was, well, I would say, a rather weak point of the Dutch way of working together. There are loads of beautiful inventions that never came to the market, simply because there was a gap in the ecosystem. And I think that is that mission-driven approach, as I call it. That is, to a large extent, the way of working that allows us really to make steps where new technologies come in a much faster way to real-life application.
Yeah, so this gap is getting smaller.
It's definitely getting smaller, yeah.
Quick enough?
For this specific topic, talking about CO2 capture and utilization and everything that connects to that, I am not fully sure. I personally feel the sense of urgency that we really have to act now. I see some companies like Microsoft, for example, making enormous pledges to become carbon neutral, even in a historic perspective. And they have reserved, for example, $1 billion to develop in the next 4 years negative emission technologies. It is not yet done then, but picking it up into a next stage, that would be the big challenge. And we need to build ecosystems to get it going. It's no longer a bilateral thing that does the job.
Okay. Mr. Hagens, when we started, you talked about the business case for the steel factory. You've put, what, 2 billion euros into offshore wind parks, or you're putting in?
We invest roughly 1 billion a year into new wind technology, because we believe that one of the drivers of all these changes is going to be electrification.
Yeah, but my question to you is this a profitable business case? And is it going to remain a profitable business case?
Well, I think the question especially is it going to remain a profitable business case? There seems to be sometimes a bit of a sentiment also amongst industry that yes, it's good, we can use electricity as a source in the future because it will be so cheap. But if it gets so cheap, nobody will build these wind parks anymore. So we need to ensure...
You're going to build them.
Yeah, we're going to build them, but of course there's a real need to start aligning the demand and the supply of renewable energy. So we need to make sure, because the business case will deteriorate if we don't see a pickup of industry to sign these long-term agreements to ensure that you get a good price for that.
But how are you going to do this? Because
Well,
we've been hearing for
PPAs.
quite a while. Industry has to become a bigger consumer of electricity, so you can put the wind parks offshore. But how exactly?
Well, one of the ideas is, of course, and you already see that in the tendering mechanisms for new offshore wind, is that you cannot just bid in. You have to present your plan, how that connects to the larger ecosystem, as you say. So you need to already now build consortia where you say, okay, we will build this wind farm, but we will also connect it to electrolyzers to create hydrogen, for example. There are also new projects coming on board where you will produce the wind offshore or power offshore with wind, but also offshore you will have the hydrogen plant, and you will not have power cables running into.
But it sounds like there's no problem, and I think there is.
No, there is a problem. There's definitely a problem because the business cases of these technologies are still out there. Everything becomes a bit more expensive. So we need, for sure, a higher CO2 price. Because if that is the problem we want to resolve, these things will only become profitable and viable with that CO2 price coming up. Yeah. And it's also quite clear. You asked earlier one of the tables, what would you do if you would become a minister? And I think it's very clear we need to start building some projects just to see if our
Yeah.
theories about it
Okay.
work.
Mr. Keurentjes.
Yeah, the giving a price to CO2 definitely is one of the mechanisms to help the development that we are looking at. I would say there is also a thing in, does oil or any fossil source has the right price at the moment? My feeling is that if you actually look at the oil price we currently have, it hampers the development of the kind of technologies that we need in the future. And if we, well, taxing might be a way, but there are various mechanisms in which you can ensure that oil has the right price. And I think that would be of great help in speeding up the developments that we need.
Okay. I saw Mr. Van Aken nodding his head in...
Well, but I think the discussion is very much about energy transition, right? You have a podcast that really talks about this. If you are working in the chemical industry like I do, it is, okay, the energy transition is one thing, but you have the raw material. Where does the carbon come from? And right now, if you look at the petrochemical industry, it is basically all fossil based. So it is oil, it is coal, it is natural gas.
Mhm.
And if you want to change that in 20 to 30 years time, it means that all the plants that you need to build right now need to be based on renewable carbon. Well, it's not what's happening. So I can see lots of investments going on in renewable energy. I see actually very little investment going in renewable chemistry. And I think that is really what is going to be the next round of, or cycle of investment, has to go into changing the source of carbon. And that is really where I see the big challenge for the chemical industry, is not so much on the energy side. I think that's where lots of people have been thinking about, but it's the feedstock. Where does the carbon come from?
Okay, Mr. Remmers, do you agree?
Well, I certainly think the core leverage is carbon pricing. I think that is one of the core elements that we really need to get the carbon pricing to a point where these investments become commercially feasible. And I'd say focus is for the energy sector on decarbonization. I think TNO talks about the recarbonization of the materials sector. I think there we have elements like circularity that we need to strengthen much more. We have the question of bio-based material that can replace some of the fossil feedstocks. So I think there's a couple of more instruments in our orchestra that we need to bring in and find the right way for them to fit together.
Yeah, Mr. Aken?
But this is exactly, it's, my view is it's not some of the petroleum. It is you have to think about how you're going to replace all of the petroleum. And that is, I think, the two ways of looking at it is it's not just that we have to slowly, very incrementally do this in small steps. But if we really want to do this and meet the climate Treaty of Paris, it means we have to do this much faster. And that raw material transition is something that we are really doing so slowly that we're not going to be seeing it in our lifetime if we go with the speed we're seeing today. So this is where the biggest change is needed.
Yeah, and how are we going to get there? What's needed? Let's all, I'll make you all minister at the moment also. I'm making everybody a minister. Mr. Van Aken, if you were in the next cabinet.
Well, for me, it will really be, this is about new technologies that have to be scaled, that have to be optimized. So it is really enabling these new technologies to be scaled. So I would really, focus very much on how to support these new technologies to be scaled, building, at least 10 demonstration plants in the coming decade based on renewable carbon. And indeed, thereby taxing fossil carbon, taxing CO2, this is just all part of it to help these business cases to become profitable. And I think Marcus and I are completely in agreement. It's not only on the feedstock, it's also on the downstream side. So it is really about making it circular. Right now, we're still losing so much carbon as waste into the environment. That is the other part. If I were minister, that is something I would immediately start addressing by making big steps in reducing plastic waste.
Okay, Mr. Hagens, which department would you like? Which
Well, I'm not sure I aspire to any department, to be honest. I admire people who take that role, but no, I'm happy on the business side of things. But what I would really do is, as stated, we need to really put the price of CO2 to a much higher level. But also we need to get rid of some of the taxes then again that really hamper the transition now. So for example, if you want to create hydrogen from electricity, you are taxed quite heavily on the use of that electricity, while we see it as an intermittent and it should only be taxed once at the consumption stage.
But about the CO2 price, we have the ETS in Europe, which has a price.
Yeah.
It's market driven, so if there's not many rights anymore, the price goes up. How would you make sure that CO2 price were going up?
Well, I would prefer it to go through the ETS, but there are of course some countries in Europe who are more or less blocking that because the problem is there's just too many rights and too many free rights. Certain industries are not in part of that. Of course, this is all going to change, but it's taken a lot of time, and that's why you see some countries now starting to say, then we will tax it ourselves. But then you create an unbalance in the playing field.
So, but how should it be done then?
I would say what I would like to see is that just ETS starts working and creates prices that are up to the 100, 150 euros.
But it means taking more rights out of the market.
More rights out of the market, but also putting more industries into that system.
But the plans are to do this, and not only industries, but...
No, the plans are absolutely to do this, but I think these plans are being frustrated by some countries who do not want to bear this burden. And
is it? Because it looks like we're going to 55% reduction in 2030, maybe even a bit more. What's the problem?
Well, the problem is that the CO2 price is currently at 25 euros, and that doesn't drive change.
But it takes time. It takes some time.
Yeah, but I think it needs to go faster. So that is my comment on this. And that means you need to take out rights faster.
Okay, Mr. Remmers, if you were a minister, maybe in the Netherlands or maybe in Germany or wherever, what would you prefer? What would you do?
Well, I think, first of all, the Netherlands is quite ahead of many, many other nations. So I think we can be proud of where we stand in the Netherlands already. I think certainly carbon pricing, incentivizing, building renewable electricity is core. But I would add one other element, which is strengthening or building on the strength that the Netherlands also had, which is research and development, and building on our talent base that we have in the universities in partnerships with industry and academia. I think these elements I see much more pronounced in the Netherlands than in any other country. And that's, I think, where these new technologies will be invented and brought to scale that make the difference in the future. So don't forget investing there.
Mr. Keurentjes, last but not least, the knowledge sector at this table. If I would make you minister, what would you do? Most important thing, your first big step.
The first step to make for all of us is to realize that in 2050, fossil sources are out of the system. If we realize that and start acting on that basis, then I think just reducing carbon dioxide emissions is not going to be enough. So we need to make the development towards the only source of carbon that we have done, and we have a carbon-based society. So the only thing we can do is utilizing atmospheric CO2. If we do it by nature, then we call it bio-based, and that works. And also the technology, and I would push very strongly to get the feedstock realized, and that's exactly the point Tom is also making. We need a CO2-based feedstock to supply us with everything we need, and that would be my...
I'm going to make you the minister. You have to become concrete plans.
It would ask for significant innovation programs, I would say on the brink between industry and academia, and it should be done fast. If I see where things are needed and seen the common development times for this kind of complexity, we need to start fast and massively. And
how should we do this? Final comment. How should we do this? You're the minister. You're the man in charge. You have the money. You have the brains. You have the power.
Tax the fossil sources and use that money to create those programs.
Okay. Gentlemen, thank you very much.